Again, very good evening, everyone. Thank you very much for your wonderful time in the Sunday evening. So we welcome you all on behalf of Chiguru Colab, and this is our first Asteroid Day celebration in our span. So today we have a wonderful speaker with us, Mr. Swastik, who is a heads of CAMS India Network, also who's a student at Indian Institute of Science Education and Research, Tirupati. So he is going to discuss about how the CAMS project is working and how we can surveillance meteorites. Yes, Swastik, it's time for you. Thank you very much for your wonderful time.
Yeah, sure. Let me share a screen.
Yeah.
Yeah. So hope you all can see my screen. Okay, so the title for today's talk is the three M's and CAMS. So here the three M's means meteors, meteorite, meteor, and meteorite. So before we starting, first of all, hello everyone. A very good evening and thank you for joining. On a Sunday
Hope
evening.
you all
can. Let me start. So before getting into the meteors, on the topic of CAMS, let me introduce first what meteors, meteorites, and meteorites are and how they are formed. So you might have heard or seen about like these pictures like this, like it's something looking like a falling star. So in this image, you can see that it looks like a star is breaking from its point wherever it is and it's coming down. Like that's how the myth of falling star came in, right? So like this actually is not a falling star, but it's something called as meteor. Okay, so if you consider stars are not something which is like pasted on a wall which can fall down after some time due to the glue got weak. It cannot happen because stars is a huge body, like of kilometers wide, and it is a moderately sized star. There are bigger stars in the entire universe, which just because they are far away, we see them as like small dots, but which are actually huge in size. And like the falling of them doesn't make any sense. So here, the falling stars is something like a rock which entered our atmosphere and burned. How? Like I'll explain that a bit later. But it's just that falling stars, meteor showers, are space rocks which enter the atmosphere and burn there, which enter in the sky and burn in the sky. So like here is another image. Like you can see that this it's like it's something a big bulb in the beginning, and then it's kind of getting a tail kind of thing. So just because they move faster, we don't see something like this, but we just see like a small dot moving fast. Okay, so like let me like before talking about these meteor showers, let us first discuss how they are formed. And to discuss how the meteor showers are formed, we have to go back to the time when our solar system was forming. Okay, so let's discuss a little history of the formation of a solar system. So like in this image, like, I'll just like, this image seems complicated, but I'll just simplify to you in some few easy words. So like about a 5 billion years ago, whatever stars you take, whatever like, any star, any solar system you take, like it's not just our solar system, but there are multiple solar systems in the universe, right? So any solar system you take, it is made from a big, huge cloud of gas and dust. Okay, like it's really, really huge cloud. Okay, so it's known as a molecular cloud. Okay, so what happens is that this cloud, which is already rotating around itself. Okay, so generally the cloud has its own gravity, its own mass, and until unless it is not like generally the cloud is floating in the space, right? So in space there is no gravity. So the only gravity the cloud will in the cloud, the only gravitation pull will be of the other particles. So it will be like one particle of the cloud is pulling the other particle, and that other particle is pulling that other particle. So there's like everywhere is pulling all the particles are pulling each other. So like for example, so for example, pulling it inside, and because of like opposite poles, they're getting equilibrium. Like, there's an equilibrium. Because of that, the whole cloud is in an unstable equilibrium. Unstable because if I destabilize it, it will fall. It will not come again back again to its position it was already in, but it it will like collapse on its own. So that's what happens when that's what triggers the formation of a star. So what happens is that like I have a cloud at equilibrium and some other outside influence, okay, that kind of affects the cloud, and because of that, the the uniformity of the cloud changes. Now the clouds does not remain uniform, and because of that, like one region becomes more dense, more like it has more gravitational pull, and that region starts pulling the particles from the outer parts inside. Okay, and this leads to a star. So now, not the like the whole this big whole cloud does not fall on to become a star. Whereas a part of the cloud becomes a star. Okay, and the remaining cloud that leads to the formation of planets. But now, what's happening is that let's say that yeah, 1 second, I just get a pen. So let's say that like 50% of my cloud became a star. Okay, so now the rest 50% is left. So like the cloud is not, the cloud is made of gas and dust, right? So now this gas and dust, like they'll collide on each other, they'll combine, they'll come along, they'll come together and start forming like small rocks. Okay, and these small rocks again will combine and they'll keep on combining to form planets. What happens is that not all these chunks, not all these rocks are coming together from planets. Some of these rocks, they'll be like floating somewhere in the sky. Okay, and that's what like, and some will lead to a planet, while some are just floating out in the system, solar system, in the space. And those stones or those chunks, those space rocks, that's those now we see as comets or meteors, meteoroids or asteroids. Okay, so now what's happening is that, so like that's how these asteroids and meteor comets they originated. Okay, so they are just a part of the earlier our solar system, you can say that. Okay, so now let's come towards comets. Okay, so comets and asteroids. So as I said earlier, so comets are more like icy dirt balls. Okay, so it's like a mixture of ice and dirt. Okay, like frozen water and dirt. Okay, so now they like similar to asteroids, they are also made from early, generally early solar system. Okay, sometimes it can happen that they are from later, but mostly they are made from early solar system. Okay, so now these comets are divided into three parts. Okay, there is a head which is in there, which is the original body. Okay, like the original the rock itself, which can be a few kilometers wide. Then there's a coma. So, and there's a tail. Okay, so how does a coma form? So coma is like an atmosphere of the comet. So as I said, comet is made from ice and dirt, right? So as the comet comes close towards the sun, the ice will start to melt, and that will kind of shine that melting, because of melting, the particles, the dirt particles which are a part of comet will start kind of shedding. So they'll start falling. The comet will start slowly falling apart. Okay, and that will form kind of an atmosphere around the comet, which is made up of generally a gaseous atmosphere. And then the particles which the comet is shedding, that will form kind of a tail around it. Okay, so this is like, this is generally this tail can be and like, as long as a few as long as the distance between sun and earth. Okay, so now that's, and then there's asteroids. So asteroids are either the early rocks, or sometimes what like that's the 99% of them. But sometimes what happens is that like you have heard about, like you have heard about how the moon formed, right? So moon was formed due to a collision of some other small size body to the Earth. Okay, so that lead to the formation of moon. So similarly, many in the beginning there were many small objects left behind after the formation of planets. Okay, the chunks and rocks I mentioned earlier. So what will happen is that these rocks will collide with the Earth. Okay, and that will, like, not as Earth but other planets, like it can be Venus, it can be Mercury, it can be Earth, it can be Mars, or and after the formation of moon it can also be moon. So these collisions will kind of throw the rocks which were part of that planet outside, parts of the planet outside, and those parts or those rocks can also lead to formation of asteroids. Okay, so asteroids can either be the early rocks or they can be parts of planets. Okay, so these are two of the two bodies which can lead to uh, formation of meteor showers. But most of the cases, the uh, comets, generally it is observed that the comets are a, a major parent body of a meteor shower. Parent body means like a body, like the body from which the particles which burn in, like, which lead to formation of meteors are separating. Okay, so now in this animation you can see that this white line you can see here, right? This white orbit. So that's the orbit of uh, a, a comet. Okay, so now as the comet is moving, that comet is shedding particles behind, right? And these small white dots you can see, those are particles. So now what happened is that as this blue dot here, you can see this blue dot here, that's our Earth. Okay, so now as Earth passes through this belt, so this belt is this belt. So what happens is that now as Earth enters that belt, these particles are attracted towards the Earth due to the gravitational pull of the Earth. Okay, and then these particles enter the atmosphere and burn there. That leads to the meteor shower, and that is why like there is a time period during which one meteor shower happens. Like for example, Perseids meteor shower only happens during some specific time. Orionids happens during some specific time, right? So like the reason is this, that uh, only when the Earth is passing through that belt, only that time we'll see the meteor. Will only that time we'll see this meteor shower. Other times we'll not see it. Like we'll not see that meteor shower. We can see other meteor showers. This is just one example. There are thousands of meteor showers which can be seen, which have been observed, and this is just one of them. So like there are multiple. Every day if you observe, every night you can see at least one meteor. Okay, but that doesn't mean that like, all the meteors are part of the same group. It can be parts of multiple groups, multiple meteor showers. Okay, so now let's come to meteorite, meteorite, and meteorite, meteorite. Okay, so like these are like generally meteor and meteorite is the same rock. Okay, but then that rock is called meteorite when it is out in the space. Okay, when it enters the atmosphere of Earth and starts burning, it's called a meteor, and when it reaches the surface of Earth, it's called meteorite. And now, one thing to note here is that a meteor, which is a part of comet, like 99.9% times, it never reaches the surface of Earth. And the reason is that it's uh, as I said earlier, it's a dirt ball. Okay, it's like really weak body. Okay, so that it breaks down very easily, very rapidly. It will easily burn in the atmosphere. But when a met when a meteor is a part of an asteroid, so now asteroid is a single bulk rock. Okay, so now when when a meteor which is a part of is made from asteroid, the meteor is also a huge single rock. Okay, and that makes it harder to burn up the whole meteor. Okay, and that generally reaches the surface of Earth. Okay, so now the meteor which are part of an asteroid will always reach the Earth, but those of comet will never reach. Okay, so until here, does anyone have any questions? I can ask right now, or else I'll move ahead.
Maybe we can keep the questions at last, I
There are
guess.
no questions,
Yeah.
then I'll go ahead with the talk. I'll continue. So now the question is, why do we want to study about the meteorites? Okay, so let's take one example. So does anyone of you know how did the dinosaurs die? Anyone? Like here in this image you can see, but I want to know from you guys. Anyone knows? Guys? Hello?
Yes, anyone can answer. Hello. It's audible, right?
I'm not sure I'm able to answer. Hello?
Yes, yes,
I'm not
audible,
sure if
audible.
it is known for sure
Hmm.
um, how the dinosaurs went extinct, but there is a theory which says that they went extinct because of a big asteroid which hit the Earth.
Yes, you're right. So it is one of the theories that the asteroid was it was an asteroid which led to the extinction of dinosaurs, and one of the evidences for that is the you might have heard about the Chingslub crater. Okay, so the Chingslub crater it was formed at the same time as that of the age of the dinosaurs, the time when the dinosaurs went extinct. Okay, so that is why it is thought that the asteroid theory is the best theory right now. Okay, so now asteroids led to the death of all dinosaurs. Okay, so now these asteroids, there are many of these asteroids currently roaming around in the our solar system. One of them someday can enter the big enough can enter the Earth, Earth's atmosphere, and if it's big enough, it can even lead to the destruction and extinction of human species. Okay, so and there have been events when many of these comets or asteroids went very close by to the Earth. Okay, so now to avoid this from happening, and at least to know like earlier, like this something like this may happen. Okay, we need to study them, to study their orbits, to study like how they are moving in the solar system. Okay, so that is another reason. So that is the reason why we need to study them. Okay, so so like, for planetary defense, that is one of the things. Another thing is that, so as I said earlier, these asteroids are part of the early solar system. Okay, so the early solar system asteroids are also known as chondrites. Okay, so by studying those chondrites, we can study the history of formation of Earth, or how the early Earth may have looked like, or how compositionally, like what the early Earth was made up of. Okay, so that we can study using these chondrites or the early asteroids. And as I said earlier, so sometimes these asteroids can also be oriented from Mars or Moon. So using those, we can also study the like we can also study the Mars and Moon's history. Okay, so so this is why we need to study about these asteroids and meteors and meteorites. Okay, so like, for just not for defense, but it's also useful for science. So here is like I'm just showing an image here. So this is an asteroid which was this is a meteorite which was collected from northwest Africa. It is named as Black Beauty. So it's a Martian meteorite. Okay, so it was originated from Mars. so which weighs about 320 grams. So now these asteroids, you can see here, it has kind of a shiny surface, right? Uh, a shiny, it has a shiny surface. So the reason is that, so as the asteroid is entering the atmosphere, it's burning. Like its surface is becoming so hot, it's melting, and that melting is leading to this shiny kind of surface. Okay, and then there are three types of them. So they are stony, iron, and stony, and they are based on the content. So if they are high in iron, they are called as iron stony. If they are high in silica, silica as in SiO2, they are called stony. And if it's a mixture of both, they are called iron stony. Okay, so now let me come to CAMS. So how in all this big picture of meteors, meteorites, asteroids, and comets, CAMS fits in. Okay, so let me first introduce CAMS. So CAMS stands for Cameras for All Sky Meteor Surveillance. So CAMS is the NASA sponsored project, and it is run currently. It is founded by Dr. Peter Jeniskans, who is a senior scientist at SETI Institute. SETI stands for Search for Extraterrestrial Intelligence. It was founded in 2010. So and then currently Miss Siddha Ganju, who is one of the coordinators of CAMS India, is the AI expert of CAMS. Okay, so the reason CAMS was founded for is to keep an eye on the meteor showers and to classify them. So there is a list named as there is a union for all the astronomical events, which is observations, events, bodies, everything. Everything has been related. So it is known as the International Astronomical Union, which is IAU. So they have a list of all the meteor showers. So the reason of the formation of CAMS was to study further these meteor showers and to classify more meteor showers, like, because the list is not full. There are many meteor showers which we haven't observed yet. So the reason to found CAMS was to study those unobserved meteor showers, to find more meteor showers. So because with that reason, CAMS was founded in 2010. So now in 2020, after the formation, there are about 600 cameras worldwide, and there are about 11 stations in all over the world. But the issue is that until 2020, there was no station in the northeastern hemisphere. So there was no station in the northeastern Asia, I can say. So to cover, and that led to a huge gap. So because of that gap, we weren't able. The CAMS wasn't able to study the meteor showers, which are only passing through this part of the atmosphere, northeastern Asia, the atmosphere above northeastern Asia. So to cover this gap, CAMS India was founded in 2020. So it is the first. It's going to be the first setup in northern hemisphere. So it was first. I can say it's a brainchild of Ms. Siddha Ganju, who is the AI lead of CAMS. So currently we have IIT Madras and IIT Tirupati in this project. So in the last 2 years, we have received about a total fund of 40 to 50 lakhs in Indian rupees. So out of that, 25 lakh was received using a crowdfunding campaign which was run in 2020 spring, and plus we have received a 6 lakh funding, 6 lakh budget per institute. So we IIT Tirupati we have a 6 lakh budget, at IIT Madras we have 6 lakh budget. So using all these amount, we have purchased the instruments which we need, which are a few cameras, video cameras, and the boxes, lenses, and all. So here in this image, you can see all the instruments which we have received at the camp at IIT Tirupati. Okay, so right now I'm leading the whole project as like I'm heading the whole CAMS heading / managing the whole CAMS network, and while also coordinating the CAMS IIT Tirupati setup, while Vaibhavi Gawas from IIT Madras is leading the setup at Madras. So now, after introducing these two, let us see how CAMS works. Okay, so now to study how CAMS works, we need to study the basic behind CAMS. So which is the ML algorithms or machine learning algorithms. Okay, so for that, I'll just take an example of a dog. So one second. So many of us have dogs or even cats. Okay, so now generally none of us, not just dogs, but none of us can survive without food, right? Let's say that I have a dog, okay, and now every day I feed him. Okay, so whenever he has a dog plate, or a bowl in which I serve him the food, and then whenever I put his dog food in the plate, he'll have a feeling of salivation. Like, for example, whenever we are hungry or whenever we see something like really really tasty, we'll have salivation. Right? We'll feel like we want to eat it or we want to eat something, right? So in similar way, whenever I serve my dog the food, he'll have salivation. Okay, so now that is the step case one. In case two, what I'm doing is that if I just I'm ringing a bell. Okay, but now as my dog doesn't know what ringing a bell means, there is no response from him. He'll be like curious what the ringing bell means. Uh, uh, he'll not know what that means. But now let's combine step one and step two, case one and case two. Let's combine these two cases. So now what I'm doing is that uh, every time I feed my dog, I'm ringing a bell. Okay, so I'll stop this. And I'm teaching him that feeding is related to ringing a bell. So now after a few days, or like let's say after a few weeks, what will happen is that now if I ring a bell, he'll know that ringing a bell means food, because every time I have fed him, I rang a bell, right? Because that he'll feel that every time I ring a bell, he'll get food. So he'll have salivation. So in earlier case, in case two, whenever I rang a bell, he did not have any response because he didn't know what the bell means. But now he knows that the bell means food. So there will be a response. There will be salivation. So in a similar way, this machine learning algorithm works. So what I'm doing is that using some codes, okay, I'm teaching my computer or my algorithm to classify some things. So for example, I want to write an algorithm. I want my algorithm to classify a dog, a bicycle, and a car. So I'll first teach my algorithm that this specific image is of a dog, this specific image of a cycle, and this specific image is of a car. And I'll not just provide one single image. Okay, I'll not just show one single image. Like if I have a baby and if I just show him an image of let's say a Doberman, okay, or if I show him just an image of a small let's say a small Alto car, okay, and tell him that this is a car, okay, so that will mean that next time when he sees Alto, only then he'll say that that's car. But any other similar body, any other similar car, let's say some Audi or some big SUVs, a big Jeep, he will not know that, he will not recognize that as car. Or let's say I teach a child that a Doberman is dog. So every time he sees a Doberman, he'll say that's a dog. But any other dog, like any huskies or hounds, will not say that that's a dog, because he has learned that only Doberman is dog. But we don't want that to happen. Right? So what I'll do is that I'll take multiple images like of a dog. I'll take 2, 3 of Dobermans, of different Dobermans, different color Dobermans, I'll 2, 3 of different color huskies, and in a similar way, I'll show all these images to my algorithm. I'll teach him that anything that looks like this is a dog, anything that looks like this is a car, and same for a bicycle. And now, after doing that, after teaching it, now if I show him any image of a dog or a cycle or a car, all the combined together, he'll classify them into three: dog, cycle, and car, which can be seen in this image. Okay, so this is a result of uh, my algorithm. Okay, so now another example is of this is the Tesla's auto car driving algorithm. So you might have heard about the Tesla's auto driving car, right, which drive on their own, which don't need driver. Okay, so they also run on a similar algorithm. So here is just one of the basic examples of how they work. Okay, so now here, now the algorithm has been taught that this specific looking car is a SUV, and this specific looking car, which has these color patterns and which has this kind of this specific object on its top, it's a police car, while this car which this much length and this much width is a passenger car, or this car is a sports car. Have this algorithm has been already taught it. So every time whenever a Tesla car is driving, it will always be observing what is happening in front of it. It will always be classifying that which car is which size car it is, and this it will always be classifying that. Okay, so this is another example of the uses of ML algorithms. So now let's get to like in all these cases, either an image or a video feed has been used to classify, as like has been used uh, to teach or to classify using the algorithms, right? So in a similar way, when it comes to CAMS, what we do is that like as I showed earlier in this image, so here is video cameras which capture all the events happening in the night sky, and it breaks them into image to image patterns. So now the algorithm which CAMS uses, it classifies these images of meteors from planes. So now, can anyone actually tell me which one of these image is a meteor and which one is a plane? Anyone? Like, can someone tell me? Is this a meteor or plane? What is this image of? The best case,
Meteor.
this
Oh,
image.
it's a plane. It's a plane.
Yes, right. So this image is a plane. Okay, so here in this image, it's a satellite. Okay, and here it is a bird. Okay, while these six are meteors, here in this small region is a small, like very faint region, right? That's a meteor. Okay, so now this in here we can easily classify, right? Like you can just looking at it, you can classify it. But sometimes what can happen is that in some cases they look very similar. Like for example, if I take a satellite, okay, and a meteor, sometimes both of them may look very similar, and now then in that case classifying them become more tedious. And in the beginning what used to happen is that in the beginning of say of CAMS, scientists used to classify these captured images with their naked eyes. But then you can't always trust a human, right? I mean, even however perfect human being is, we are bound to get tired, and more tired we get, we make mistakes, right? So what that used to lead to misclassification of data. That led to the idea of uh, writing a machine learning algorithm or AI algorithm for the CAMS. So now the AI algorithm which CAMS uses, it has been taught using the earlier images of meteors. So not just meteors but other objects. So the planes, then birds, satellites, and meteors, using all these many images which were gathered during the first year of CAMS. This algorithm has been taught, and and based on what it has learned, it classifies the images. So now another interesting is that it does not just work on the first 1 year data, but what it does is that at the end of every year we collect more new data which has been classified using the CAMS algorithm. So now using this classified data, which CAMS algorithm itself classified, it will learn again, and that makes it more precise. So at every time it's learning and classifying learning, this process repeating, which makes the algorithm more and more precise. Okay, so I will not get more into this, like how this algorithm works. I just tell you that this parallel by LSTM is the algorithm which has been used for CAMS, and you can see it has the most precision and most recall in all the similar models. Okay, and that is why this model has been used. Okay, so precision means that the amount of the amount of true like true values. So amount of, let's say that meteors, amount of classifications which are actually meteors. Okay, so so you can see that the precision of the CAMS algorithm, which is the parallel Bayesian algorithm, is about 97%. Okay, so that is the one of the most precise algorithms which has been used in this classification, and that is why CAMS is currently one of the best observatories, I can say, which are being used for this. Okay, so now the CAMS, as it's a citizen science project, the data collected for CAMS is available for everyone. I mean, anyone can get access to the data, and it can play, and he or she or they can play on the data and study the data on their own. Okay, so now like the CAMS algorithm itself, what it does is that using the raw data, it can classify the it classifies using the raw data. It first it finds out that where this meteor came from in the sky. Okay, so which is something known as the radiant of the meteor shower. Like radiant means like a point in the sky from where the meteor looks like it's coming. Then it also figures out that what comet this meteor is a part of, and then based on the this pattern of the meteors, it can also classify. It can also generate an orbit for that comet or asteroid, and because of that, and this can tell us that when the Earth may cross the that orbit of the comet and when they may crash. So because of that, we can very early we can know that like when something like this may happen. That is one of the applications, which is, as I said earlier. And then as a citizen science project, so anyone can do generally the raw data which is collected by CAMS is available for anyone. So because of that, anyone can download the data, get the data, and do research or internships on this. So like right now, as CAMS India is a part, as CAMS I said, as India is a part of now CAMS. So this data collected by CAMS will be available for IIT Tirupati and IIT Madras. So because of that, and it's just not the raw data. I mean, as these two stations are parts of CAMS, they'll also get the process data, and using which many research opportunities, not just in astronomy, uh, but astrophysics, computer science, AI, and geology can be done. So, like this has this data is it's available to public. They can also do all this research on themselves, and it can give you more and more opportunities, more and more experience. So one of the examples is Ramakrishna, who is the BSMS, who was a basic 50 student at IIT. So he had done a project with the CAMS, and he currently has a paper published first of the paper published on his name. So now, after this, let me discuss about how uh, CAMS is related to asteroids. Okay, so as I said, meteorites. So as I said earlier, uh, CAMS can study the paths of the meteors, and based on this, it can calculate the radiance, the orbit of the comet, and all. But as it's studying the path of the meteor, it can also guess that if the meteor falls down, where will it fall down? Okay, so uh, like the meteor will follow a path, and that path can be calculated using CAMS. Okay, and then using that path, one can find out where the meteor may have fallen, and collect the samples. Okay, so there have been many such sample runs, uh, one of which in Sudan was led by Dr. Peter Jeniskans, where these using the CAMS data, the meteorites were collected, and this collection of meteorites can help geology students get more and more experience in classifying the meteorites, studying the meteorites, and using these meteorites, studying the history of the not just Earth but the solar system, and if it's and the other planets. Okay, so this is this beginning. As we go more and more into camps, and as the this setup gets more and more settled, the opportunities will increase even more, and that gives like many opportunity, and that leads to like for example, the mentors like there are many companies, like for example, one of them is SpaceML, which is a part of CAMS, which can help you in all this process. So as uh, CAMS is part of SpaceML, because of that, it is helpful for a student to gain knowledge from these, and because of as it's part of CAMS, it's easier for them to help you and mentee you. So with this, I'll stop. Thank you very much. So if any one of your questions you can ask, I'll stop sharing my screen.
Yeah. So really, thank you, Swastik. It was a really wonderful talk. You have shared amazing facts about the camps project. So where students can get amazing opportunities. Yes. So the floor is open for questions. Participants, you can throw questions.
So earlier you had shown a meteoroid from Mars, right? There was a meteoroid and you mentioned that it is from Mars.
Mhm,
So
mhm.
does that mean it's a part of Mars? Or like, how do we know it was from Mars?
Okay, so generally, what we know is that the composition of Earth. Okay, we have studied the surface of Mars. We have studied the surface of Moon, right? And based on this, a basic idea of the compositions. That's first thing. Second thing is that now we have studying the path of the meteorite, that meteorite, we can study like the origin of the meteorite, and that can help us get a basic idea. But the major part is the compositions. So like geological composition of uh, earth rocks and then Mars rocks differ a lot. Okay, and like you can also see it using the server, like the light itself, like image itself. Mars looks more red in radiation color because of its high iron content, while Earth's crustal rocks have high amount of silicates in them or silica content in them. So if it was a rock, and as Moon is from the same, it is also a similar content. It's a leucogenic body. So now, as the if you study the composition of the rock, the composition can tell us a lot about its origin. And based on the composition, we know that it came from Mars. It's more of
Okay,
a
that makes
geological
sense.
study rather than a astronomical study.
Okay, thank you.
Yeah, yeah, sure.
It was a good question. Yeah, from others.
Does India have only two camps from IIT Madras and in Tripur?
Right now, we have a third set. We are working on a third setup. So we are like, it's not ready yet. So like, we have not finalized about the third setup yet. It may be in Triple IT Sri City, but we are not yet sure about it. So we are still working on it. So CAMS is more like, does not work on a single setup, but it's more like a triangulation. So we need, what we do is that in CAMS, there are three setups which are kind of from a triangle, and what it helps in
Like
with,
a constellation.
sorry,
A constellation, is it?
no, not constellations. I'm saying is that the three setups on in India on Earth, they form a kind of a triangle. Okay, so let's say that I have a setup in IISA Tirupati, I have one in IIT Madras, and the third setup will be such that they will form a triangle, uh, which kind of an equilateral triangle, I'll say, which are located at about 80 to 120 kilometers afar, each of them. And that helps is in that sometimes one of the setups will observe something, okay, which may be in plane or maybe some like uh, uh, atmospheric turbulence. Okay, so if just one setup is there, then it will be harder for the algorithm to classify if it's plain turbulence or uh, a meteor shower. But then it's a meteor shower, it will be observed by all the three stations. Okay, so now that helps us to classify if it's actually a meteor. Like, that's kind of a first step. If it is observed by all the three setups or not. If it is, it may be a meteor shower, and then it is classified further ahead, or else the image is discarded. I hope I answered the question.
Yeah, it was very good answer. And I mean, one more point I can add: the CAMS project, which is in one in IIT Madras and another in ISER Tirupati. ISER is an institution, Indian Institute of Science Education and Research, not in Tirupur. It's in Tirupati.
Yeah.
Yeah. Okay.
Okay, so thank you.
Great. Any other questions? Okay. If no more questions from the participants, and maybe I can ask one more question. Swastik, is there any way can people like the amateur group or researchers, independent researchers, can build CAMP project?
Yeah. So actually, one of the things CAMS is like, one of the helpful things that CAMS is it's a citizen science project. So because of that, if you want to classify the data, like if you want to see the data, you can actually get it online. Okay,
Mm-hmm.
so like on CAMS website. And if you want to participate in CAMS, what you'll need to do is that you'll need to have like generally if it's a big institutions, we prefer to have 16 cameras per institution. But there are many cases when the setup is on at a home, like on terrace of a home, something like that. So in those cases, even one, two cameras setups are also there. Only thing what we need is that three setups should be there, which are spread across like 120 to 80 to 100 kilometers. So if like amateur astronomers groups which want to participate in camps can find even three homes like which are which can participate in this. It's like more. They're welcome to join in, and it's not very costly. I mean, one camera costs about 10,000 rupees, and one lens costs about like 5,000 rupees. So if you have a desktop at your home, and let's say that you want to buy two cameras, then in about 30,000 rupees, you can set up one station, one in about 1 lakh rupees. I'm considering like all the three setups. So in about 1 lakh rupees, you can set up a whole station.
Okay, so that's really interesting. Is there any way, the CAMS India network can support the people to build such initiative? Is there any provision under India network?
So right now we are like in the building stages. Like the CAMS India setup is not yet have had its first light. Okay, so right now, the only support we can do is that we can provide with the help, like not financially, but we can provide you the contacts for uh, like contacts for support for the financial support. CAMS India itself is working on the funds from CAMS and ISA Tirupati's funds and IIT Madras funds. We don't have our own actual funds. So because of that, we can't fund other setups, but we can help you in getting funds.
Oh, okay. That's really helpful. I'm asking, other than financial support, if we have a camera, we purchase something, can CAMS India can help, how can electronic system have to arrange, kind of
Yeah,
technical support?
yeah, we can do that. We can do that. Actually, the thing is that all this we already have a list of all the instruments that you need, which I can easily provide. Like we have, and then that all the instrumentation which we need to do is already on the website of CAMS. Okay, and it's very pretty easy. I mean, the installation of the algorithms, it is done by it is done remotely by the people at SETI, and then for the instrumentation, only thing you need to do is that the focus of the cameras and the cables, which we can easily help you.
Okay, great. So really, we will get once we frame something. Thank you
Yeah,
very much. Is there any more questions, participants?
Yes, Surendra, I would like to.
Yeah, please.
Yeah. Hi, Swastik. Thank you for the talk. Yeah, this is a general question. Since I'm an educator, most of the students don't know about their entry into ISOs or
Mhm.
ISOs are existing, especially those students who are from the rural area or marginalized background. So, can you give a small or a path or entry path into ISOs in as a very general stuff? Maybe if you can, yeah.
Yeah, sure. No, no. So generally, admissions to ISER, they are after your 10 plus 2 standards. So any science student who has finished his 10 plus 2 can apply for ISERs. So now there are currently three streams for the admissions. One is the state central boards or ISA to test exam, which is run by ISA themselves. Then there is the KBY, or known as Kishore Vaigyanik Poshan Yojana, which is run by ISC, and then through JE Advance. So via any of these three channels, if you qualify for any of these three exams, you can apply for ISAs. So
Okay,
the
sure.
KBY happens, I think it is for 11th, 12th, and BSc first year. And ISA2 test you can try for 3 years. So KPY, I think that will happen in November. Aptitude test this year is happening in July, I guess, or yeah, I think July only. And then advanced is again in June, July time.
Okay, okay, that's great. Thank you.
Yeah.
Nice. Any more questions from participants?
Yes, sir.
Yes. Yes, you can ask. Varsha. Varsha, do you have any questions? You are muted. Just unmute and speak.
No, sir.
Okay, fine. Okay. Okay, if there is no more questions.
You can contact me at this email ID. We can talk there.
So there is a question in chat box. Is there any workshop for school students?
Yeah, yeah. CAMS itself, we have had a few sessions earlier for SOS students. Generally, if we haven't had any hands-on sessions for school students because AI itself is a very hard thing to learn. But we do basic. We have done 2, 3 basic workshops about meteorites and like how CAMS works, etc. We generally don't do this AI workshop because it's for 10th, 11th, 12th students. It can be a little hard.
Okay, great. So thank you. If there is no more questions, maybe we can wind up the session. Maybe we can open the floor for another 30 seconds for questions.